Hey guys, Chili here. Welcome back to Intermediate C++ Tutorial 17. Today we're talking about inheritance, the concept of waiting for your parents to die so you can sell their shit. Now, inheritance is extending the functionality of some class without modifying the class itself. Let's take a look at this simple code here. We got a class A, it's got a function, it's got some variable. We got a class B, and this colon after here, colon public A, means B is inheriting from A. And then we declare B with a function and a variable. So what is this going to do? Well, if we go my A dot, we see that it has function X as a member. That's fine. If we go my B dot, it has function Y, but it also has function X that was inherited from its parent, class A. So it gets what its parent has. And if we do see out with the size of these two guys, we will see that the size of A is 4, but the size of B is 8, because B has the member data from here, the float var2, but it also has this data that was inherited from A. So when we inherit, we get everything that the parent type has, plus whatever extra we want to add in on top of that. And the parent type remains completely untouched throughout this whole process. Now, this concept is at the core of object-oriented programming. Some would say this is maybe the most important feature after classes themselves. So we're going to be taking a couple of videos to explore this in depth. And when you learn to properly harness this feature, it's going to unlock so much more software engineering techniques for building advanced code architectures. Now, when you read up on inheritance online, you're going to see people using a whole bunch of different words to refer to the same shit. It can be confusing, so let me just go over that quickly here. So when we use inheritance, we can say, we're inheriting. That makes sense, right? We could also say we're extending or we're deriving. We could say we're subclassing, although this one isn't that common. Now, the thing that we're inheriting from, we can call that the parent, but we could also call it the base, or in Java, they call it the superclass. And the new class that we're creating by inheritance, we could call it the child. We could also call it the extended class or the derived class or the subclass. Again, subclass is a Java thing. Now, personally, I'm not going to be using the Java terms. I'm mainly going to stick to these guys here, inherit and parent class, child class. But I may also, use base class and derived class as I'm talking. I might slip up to it. I use them interchangeably. So that's great and all, but the next question you should be asking is, why do I care about this feature? Well, let me give you an example. Let's say you've got a program, you've got a class X. It's got two features, the red feature and the yellow feature, and it is used about 200 times in your program, the class X here. Now, you have got a couple of places in your program where you need a class that has the red and the yellow features of X, but it also needs an extra feature. But these ones are only going to be required in a couple of places in the code. So how do you do that? You can't use X directly as it is because it doesn't have these features. Well, you could try to add those features to X. But remember, the places where these features are actually required is only a few places in the code. So for the vast majority of the places where this class is being used, these features aren't really required. You're adding a whole bunch of extra junk to this class that is mostly just going to be useless, and it might end up eating up more memory than you really need. So that's not too great. The other thing you could do is you could take basically the definition of X, copy and paste it, and create, 3 new classes A, B, and C. Just copy and pasting your code. And then you can add the extra features you want to these new classes. And that would work fine. You wouldn't have the waste. You wouldn't add a bunch of unnecessary junk into class X. But you would be copy and pasting a whole bunch of code, and that's shitty. You don't want to be repeating yourself in programming. We've covered this already. So what we do is we make A, B, and C inherit from X. That means that they get this stuff automatically, and then they can extend the functionality of X by adding features like this. And this gives us the advantages of it doesn't clutter up class X with a bunch of stuff that is almost never going to be used. and it uses the least amount of memory that we would need, and you're not repeating yourself like if you were to copy and paste this bullshit. Another advantage to inheriting over just adding the features to class X is you've got class X here. Let's say you've already debugged and tested all this shit, and it is working in 200 places in your code. Now you don't want to start going in there and modifying it and changing stuff. You might be breaking stuff that has been worked. You've already debugged, you've tested it, you've got it working and solid. You don't want to fuck around with it. Now let's take a look at a little more concrete example here. We've got a class smasher. It's got HP, it's got strength, it's got a name, it's got a bunch of getters. And it's got two main functions here, smash and take damage. So smash allows one smasher to smash another smasher. And it just narrates what is happening, and then it calls take damage on the victim. And take damage, it just adjusts the hit points, narrates what is happening. So it's very simple. And here we create a couple of smashers. DF smashes TB, and then TB smashes DF a bunch of times. If we run this, we see that Torbjorn smashes the shit out of Dickfuck. So this is great, good times. But now let's say that some smashers should be elite smashers, and they should have access to a special attack called the Super Smash. Now we could just add the Super Smash to the class smasher. And I mean, that would work, but it's not very good design, right? Because normal smashers should not be able to use that function. So instead, we want to create a separate class. And we could, again, like I said, copy and paste smasher, call it elite smasher, add the extra function, but we don't want to copy and paste. We don't want to duplicate all this functionality. We don't want to repeat ourselves. So we do class elite smasher, and we inherit, so that's colon, and then public, and then smasher. This is how you do inheritance. And now elite smasher is inheriting from our smasher. Now regular smash does damage by just basically the amount of strength you have. So it gets your strength and it calls take damage on the opponent with that amount of strength. So we want to do something a little more powerful. So what we're going to do here is we're going to call take damage get strength times 2. But Super Smash, let's say that Super Smash requires SP in order to use it. So you've got a finite amount of SP. So we're going to have to add SP to our character here. So we go private int SP. And we'll just say that all elite smashers start with 6 SP. And there you go. Now we have an elite smasher. We just had to add these two members, and it gets everything that our parent class has. Now we can turn one of our smashers into an elite smasher. We'll use the default constructor for this. And let's have our elite smasher use Super Smash a bunch of times. So now our elite smasher is using Super Smash, uses it a bunch of times, runs out of SP, and yeah, that's how it works. Now there's a whole bunch of interesting stuff that is going on here. We got to unpack this. First, the most interesting thing. So the smash function of smasher takes a reference to a smasher. That's the target. And we call that here on TB, but TB is an elite smasher. This is not a normal smasher. So we're passing an elite smasher to a function that is not expecting an elite smasher. Why does this work? Well, we call inheritance an is a relationship. What does that mean? Well, an elite smasher is a kind of smasher. And because it is a kind of smasher, we can pass it to functions that expect a reference to a smasher. It doesn't matter. Let's look at it a different way. So we can look at Elite Smasher as a kind of like a Matryoshka doll, right? It's got a smasher inside of it. And then it's got some extra things that it has added to that functionality. Now, if we access this with a reference to Elite Smasher, then we will have access to the entire functionality of the Elite Smasher class. But if we access it with a reference to just a smasher, then we're only going to have access to the part of this Elite Smasher that was inherited from the Smasher class. So here in code, I can do smasher reference ref is equal to TB, and that's no problem. I can have a smasher reference to an Elite Smasher. The other way, not so good. If I try to get an Elite Smasher reference to a normal smasher, obviously that doesn't make any sense because normal smashers don't have the functionality of an Elite Smasher. You can't do it like that. And this ability to refer to a child type with a parent reference allows us to create functions that can work over a whole bunch of different types as long as they all inherit from a common parent. For example, here the smash function works on any target that inherits from smasher because it takes a reference to smasher. Now, other thing you might be wondering about is why is our elite smasher so goddamn weak? And also, why did I make this a default constructor here? Well, it's all related. So the reason why Elite Smasher is weak is because the default constructing the Elite Smasher is going to end up calling the default constructor of Smasher, which gives it a strength of 1, and the name of Mick default, which you saw in the output there. So, well, why did I make this a default constructor? Well, if you don't make it default, see what happens. So here you can see if we try to call it with a parameterized constructor, we got problems. And the problem is that constructor doesn't exist. You might be saying, well, sure it does. We've got the constructor here. We inherit that constructor and then we call it. But no, you can't inherit constructors. That's the main takeaway here. Constructors are not inherited. And you might be saying, well, Chili, I mean, the default constructor was inherited, right? Because when you default constructed Elite Smasher, it called the default constructor of Smasher. And that's not really how it works. So let me show you something here. If I delete the default constructor from Smasher, it tells us that the default constructor of Elite Smasher cannot be referenced. It is a deleted function. And some of you might have recognized this from an earlier situation, but basically what is happening is when you don't specify any constructors, the compiler creates a default constructor for you, right? And what it does in that default constructor is it default constructs all of the members. Okay, so far so good. Now, if one of the members cannot be default constructed, then the compiler-generated default constructor is defined as deleted, all right? Because how can it do it? It can't default construct one of the members. Well, here's the thing. The base class of a class is sort of like the first member, the first data member of that class. It behaves like that in a lot of respects. So, when you go to construct an Elite Smasher, the first thing that is constructed is the smasher that is inside of it, like a Matryoshka doll. So if I try to explicitly define a default constructor here, what's going to happen is the compiler is going to say, no, fuck your shit. You have to initialize that smasher because it doesn't have a default constructor. So how do you do that? Well, all you got to do is you type in here, smasher, just like any other member variable, and then you call its constructor. And you do that like this, and now we've got a constructor for our Elite Smasher. Now, remember I told you that the order of initialization of an object, its members are initialized according to the order in this list, top to bottom, and that's true, only one caveat. The first thing initialized in a class is the parent class. So the first thing that is going to be, the first constructor that's going to be called is the constructor for Smasher. And then it will initialize this guy. So now we call our proper constructor for Elite Smasher. We give him a beautiful name like this. And as you can see, he totally messes that shit up.
Why, you little... I got you! Go! Go!
It's all just an act.
Stop! Stop! He's already dead.
Alright, so Super Smash uses 3 SP, right? So you can only really use it twice, and then you're done. So let's change the system. Let's make it so that when you use a normal smash, you also recover some SP. Now, we can't add that functionality into Smash here because this class Smasher doesn't have an idea of SP. It's not possible. So how do we do it? Well, what we can do is we can actually just take this function and copy it into here. And this is called overriding. So you can redefine the same function in the child class, and it will override the implementation of this one. This one will no longer be called, when we call Elite Smasher.smash, it's going to call this function now. Now, one thing you're going to notice right away is, what does it say here? Member name is inaccessible. What is this? This is, well, name is just one of my member variables. How can I not have access to my own member variables? And this is one of the things that you've got to know about inheritance, is that the private members of the parent class are not accessible to the child class. You can't touch your parents' privates. Don't do it. It's fucking weird, man. So all we got to do for that is just call getName to get those guys. So now we have the original functionality of the smash function. Now all we got to do is add our own little twist to it. So we output a little message and we add 2 to our SP. Now we're not allowed to do this because smash is a const function. So let's just remove that. And we can remove the const here because this is a different function than the smash in the parent. So we don't have to make it exactly the same. So there we go. Now Elite Smasher has a little bit of a different smash. It allows it to recover some SP. So here our Elite Smasher will try Super Smash 3 times, then it'll smash a couple times to recover some SP, and then it'll use Super Smash again to finish the job. There you go, Super Smash, run out of SP, recover some SP, Super Smash again, kill that fucker, and then there you go, you're done. So this is great, right? Not only can we extend the functionality of Smasher, but we can also alter some functionality if we wanted to. The only problem with this is that we're basically copy and pasting the smash function into here, and then adding a little bit at the end seems kind of inelegant. It would be much nicer if we could just call the parent smash in here and then add our own flair at the end. And we can. We can't just do, smash target, because that'll call the smash of Elite Smasher and it'll just be a freaking infinite loop. But what we can do is we can specify that we want to call the parent version. So we can go smasher : smash, and that now that invokes the parent version. We get the base behavior, and then we can add our own behavior on the end. And we can see this works exactly the same, only it's a hell of a lot more elegant. So this is a very common pattern. Override the behavior of a parent and invoke that behavior inside of the overriding function, while also adding your own little embellishment on there. All right, let's give the Elite Smasher another special ability. We're going to call this one Pep Up. Now, what Pep Up does is it takes 2 SP and it gives you some hit points and increases your strength. So it's a nice little buff here. Now, the problem with this is that we can't actually access HP or strength. We can call get to get their values, but we can't set their values. So this is obviously a problem for us here. What are we going to do about it? Well, as you know, class access is controlled by these specifiers here, public and private, but there is one more specifier, and that guy is called protected. And what protected says is that people from the outside world cannot access this, but your children can access this. So it's a kind of access control in between public and private. So we're going to make our HP and strength protected. We're going to keep the name private because the children don't need to change the name. And now this stuff here is no longer giving us an error. We can call our new Pep Up function and it just works. There you go. Uses Pep Up and gains 30 HP and 10 strength. His boner is so huge. So there was a third access specifier hiding out there the whole time, and this one only makes sense for when you're using inheritance, and it gives you a little bit of access between public and private, allows your children to access some things but still keep them private from the outside world. And of course, this works not only for data members, but also member functions and inner classes. Anything that's a member, you can specify it as protected. So as you've just seen, if you want your children to have access to your data members, you've got to make them protected. And you might say, well, I'm just going to make all my data members protected, then no privates, problem solved. But I mean, the private keyword is obviously there for a reason. It must be good to use sometimes, right? And it is. If you make data private, your children can't access the data directly, so it insulates them from changes to the base class's internal implementation. And that's a good thing, right? That's encapsulation. Now, there's basically 2 ways you can approach this problem. 1, you make the data protected, children have access. 2, you make the data private, but you make a protected interface. So you can make setters and getters or other functions that will allow the children to have indirect access to that data. And that's the same idea as you do for your public interface. So what protected will allow you to do is to have a separate interface only for your children. And that's great, but it is also a lot more work. So the question is, when do you make the data protected? When do you make a separate protected interface? And the C++ FAQ is a great resource here. It basically tells you, well, first of all, to the question, purists might tell you never use protected data. It says that's bullshit. The real world is more complicated and there are different factors. So how do you decide? Return on investment. There is going to be some situations where it is going to be worth your time to build a separate protected interface, and there will be some situations where you say fuck it and you just make the data protected, and that's fine. And it depends on a bunch of things. It depends on the size of the system, it depends on who is creating the base classes versus who is going to be maintaining the derived classes. There's a lot of different factors, but as a beginner, I'm going to tell you, it's okay to make your data members protected. Don't worry about it too much. It's the same as all encapsulation things. If you go too crazy on the encapsulation as a beginner, you are going to get turned off. You are going to have your growth stunted, and it's going to be a bad time. So don't stress about it too much. Don't write it off. Don't throw it away as encapsulation is stupid. That's dumb. It is not stupid, but as a beginner, you can't stress over it too much because you're not good enough to use it 100% is what I'm trying to say. So don't worry about it making your data members protected right now. As a beginner, it's okay. I give you license to do that. And by the way, I recommend you check this page out. It's good shit. It's got a real good talk here. So read this stuff up. All right, so we have learned a bunch of techniques related to inheritance. Now let's review them, make sure that you understand them. Number one, how to inherit. Well, you use the colon, you inherit from a class, and then in your inherited class, you can add additional members. The next thing we learned was the fact that you can use a pointer or a reference to a base class to refer to any child of that class. Very important. We learned how parent classes are handled in the constructors of the child classes. And we learned that you can override existing functions in the parent class. You can override them in the child class, give them different behaviors. You can also invoke the parent version of an overrided function if you want. And we learned how to use the protected access specifier to, specify members that will only be accessible from the child, but not from the outside world. So it's access in between public and private. Now, I guess some of you are going to see this inheritance stuff. You're going to say, this is really cool shit. I can't wait to try this out all over the place. And, I like that enthusiasm. I hope people can get enthusiastic about the new features that I'm showing them. But we need to cool it down just a little bit. And I'm going to tell you why. So among programmers and even OOP programmers, there is a small but very vocal minority of people who are going to tell you inheritance is fucking terrible. Never use inheritance. It's the devil. And I think there's a reason for these people existing. And I think the reason, if you hear their stories, is that they have at one point in their life embraced inheritance and they have just used it all over the place willy-nilly. They've gotten fucked, and then they've decided, well, this tool is the devil. It has fucked me. It is the devil. Now, the thing about inheritance is if you use it too much and in the wrong places, it's going to be terrible for you. You've got to know when to use it and how to use it. And you don't really know that yet. I've just introduced it to you. So that's why I say I want you just to chill down for a second and don't start using it in every project. If you've got like a project, a fairly substantial project you're working on, and you're now going to run off and, refactor it to all use inheritance, just chill out. Don't do that. I recommend that you take time and that you experiment with this stuff in a sandbox, in a simple environment, and try out all the different permutations. But maybe just cool down a little bit on actually using it in a real project. Take a look at this question here on software engineering. Why is inheritance generally viewed as a bad thing by OOP proponents? And the question right here is it's a myth because it is not generally viewed as a bad thing. Look at the top voted question here. Disagree with the premise of the question isn't generally viewed as bad. what it's viewed as misused and overused, which is correct, especially the phrase favor composition over inheritance. When it was written, like 20 years ago, inheritance was used way too much. And the people who wrote the book about design patterns called The Gang of Four, they basically said, okay, guys, you gotta chill out on this inheritance shit. Not everything is inheritance. But even the Gang of Four dudes, they say in a bunch of places here that inheritance is useful and, pretty much essential. So the takeaway from this is that programmers who know what they're talking about aren't going to tell you don't fucking use inheritance. What they're going to tell you is don't fucking overuse inheritance, which can be said about basically any feature of the language. So what I'm saying here is I like your enthusiasm, I like your optimism, but just chill out on inheritance for a little while here. You've just learned it, so just focus on, experimenting with it in a sandbox, the basics. And as we progress through the tutorials here that I'm going to be doing on inheritance topics, I'm going to be giving you some more advice about when inheritance should be used and what other techniques can be used instead of inheritance or to complement inheritance. And I'm also going to be giving you, a bunch of concrete examples of good uses of inheritance. But that's going to about do it for today. If you haven't already noticed, this is a two-parter, so stay tuned for part 2, where I'm going to introduce to you a new inheritance paradigm that's different from the extending a concrete class. I'm going to introduce to you a new modifier for class members. It's not related to inheritance, but it's something that came up, and I'm also just going to give you a more detailed and concrete example of using inheritance. But until then, thanks for watching. Hope you enjoyed the video. If you did, please click the like button, it helps a lot, and I will see you soon with some more C++.